Can I explain quantum entanglement in a more visual way? Sure, all I need is a coin. The sides of this quarter are entangled. They depend on each other. If the tail side is facing you, you know that the head side is facing me. And if the head side is facing you, you know that the tail side is facing me. Now I'm gonna flip this coin. Off camera. Haha, I did it. Now you have no idea what the state of this coin is. It has a 50% chance of being heads and a 50% chance of being tails. That is essentially a quantum particle in superposition. It could be in either state or another state. It is essentially in both until you observe it. So now I'm going to let you observe it. It's heads. We've observed this coin and we know 100% that it's heads. What can you tell me about the face that is face down on the table? It's tails, right? See, that's the thing. You know that it's tails, even if you don't observe it as tails. We are not observing the other side of the coin right now, but we know it's tails because the two sides were dependent on each other. They were entangled on each other. And when we do observe the other side, sure enough, it is tails. Now imagine you have two quarters. They both flip independently. Doesn't really matter. But then a scientist comes along and takes one of the quarters and puts it on top of the other. Now the coins are flipping together. And you know that if this one is heads, that one is tails. Now we can flip these pair of coins and hide them. And then after we hide them, we separate one far away from the other. Now again, depending on what an observation of one of these coins is, you'll know what the other is. So now we're going to take an observation. This coin was heads. That means the coin under my scientist buddy here is tails, and we know that even if we don't observe it. And sure enough, if we do, it's tails. And we can do that in reverse. We observe tails first, and then we know over here, it's heads. That's because when we put the two coins together, when we entangled them, we made their results dependent on each other. The problem is, this entanglement only sticks if you don't do anything to the coin. Like, the coins are on top of each other now, and I move one and flip it. It flips just fine. They're no longer dependent on each other. Only if we keep them entangled and dependent can we keep this relationship up. And that's why you can't use entanglement to transmit info, because it's kind of like that. As soon as you put in info you want to transmit, the entanglement breaks. The only thing you can do is observe. And that's a vast simplification, but that is essentially entanglement.